Recording now. So I'm going to just walk you through this final exam practice worksheet. So this is like a study guide, and it's obviously not everything that is in the course was here, but at least all the important pieces are here, and anything that is relevant to those concepts, more stuff, you should look at the lecture videos, look at the review, other reviews, you look at the specific examples shown in the extra credit problems, in the homework problems, all that. So it's like you have to review everything. So it's just not just this worksheet, but this is like some idea that you can get, like, are you prepared for the exam or not? So those things, okay? All right, so here is the, first of all, you will get some questions that relate to nomenclature and formula. So for the nomenclature, you guys need to look at the ionic and the covalent naming, right? And so in the ionic and covalent compounds, as you can see, as you can see that, for example, ammonium sulfate, right? So you should know the polyatomic ion. You should know the ammonium, like ammonium is NH4 with +1 charge, and sulfate is SO4 -2 charge, okay? And then you guys know that it will be crisscrossing. So this number comes here and this number goes here, okay? So what does this become? This becomes NH4 because more than one is being crossed over. So this becomes 2. And then when it's just one crossed over, we don't put the other polyatomic ion in bracket. We just leave it like, as it is. So this is how. So revisit, in case you are rusty on nomenclature, excuse me, revisit the worksheet on nomenclature. All right. For example, lead chromate. So this is, you should know what is this group. This is the dichromate, okay? And then lead. And so dichromate is actually, so this is, let me make this thin. This is a bit too thick. Should be okay. Okay, lead. So lead, Pb, okay, is going to be in +2 charge because Cr2O7, this is a dichromate polyatomic ion. So this is -2 charge. So here, when you crisscross, they cancel each other out. So +2 and minus cancel each other out. That's how you get lead. The name is still lead dichromate, okay? The name is lead dichromate. So the name would be lead. And since this is in 2 state, lead 2 dichromate, okay? That's the dichromate ion. So I have like, this thing. So potassium dichromate. Now potassium is +1 charge and dichromate is Cr2O7 -2. So here you see when this is crisscrossing, so this is +1 charge and the other is -2. So this comes here and this comes here. And so what do you get here? You get K2 Cr2O7. K2Cr2O7, okay? So like that. So, you need to practice these. Then nomenclature, naming, like tin SN2. So this one, SN, S2. So has to be 4 +4. And S2 is -2. So when you crisscross, this number comes here and this number goes here. Okay, so when you are crossing this, then the +2 and -2 cancel out, +4 and -2 cancel out. So what does this become? This becomes SnS2. Okay, and the name is tin 4 sulfide. Okay, so these things. So I'm just doing a little, like if you've forgotten this, so hopefully you can remember this. So let me make this small. This was too much space. So here, once again, we are talking about ammonium sulfate. Ammonium sulfate, NH4 +1, and sulfate, SO4 -2. And when you crisscross, this number comes here and this number comes here. So this becomes NH4 whole twice, okay, and then SO4. Okay. So So these are just some examples here, but the rest of it is you guys need to practice. Now, regarding the theory-based and the knowledge-based questions. So I have another video I already posted, and the link is already available in the link is available in the modules. And the video on this is on the YouTube also. So watch the video in the YouTube, and that link is available. And so, you know, so I'm walking you through the theory based. Now, the interesting thing is the math based questions, you do get some points, right? Partial points. But for theory based questions, there is a problem. The theory based questions, either you get it right or you don't. So it's very important that you focus on the theory. Also. Okay, so here you're going to watch the video on the theory-based questions, and then that should be okay. So these are about 33 questions. Okay, so this was already covered. Now we are going to look at the calculation-based questions. Now these are all the charges, right? So this is, you have to look at the solubility tables. So in the solubility tables, you have ammonium phosphate. Remember ammonium. Ammonium is always anything that attaches to ammonium is soluble. So this is AQ. Okay. Next is barium nitrate according to the solubility table. So look at the solubility table. Solubility table in the handout. And that table will tell you that, now you should remember also that all nitrates are soluble in water. So it's AQ. Now barium phosphate. Phosphates, all the phosphates are insoluble in water, so it's S. Okay, it's solid. So this is the guy that is forming the precipitate. And then ammonium nitrate, again, ammonium and nitrate, anytime they attaches to something, it's always soluble. So this is AQ. Okay, so next is balancing. So you see how many, so let's do this balancing. Let's see. So there are 3 ammoniums here, and here I'm going to bear. So it is okay to not put okay. So what are you going to look at? PO4. How many bariums there are? There's only 1 barium. And how many nitrates there are? There are 2 nitrates, NO3, right? And then how many bariums do you have here? 3 bariums. How many phosphates do you have? 2 phosphates. Then how many ammoniums do you have? 1 ammonium, okay, 1 NH4. And how many nitrates you have? 1 nitrate. Okay, so here in this case, you will balance, right? After that, you're going to put the charges. So I'm not going to do the entire thing for you. You have to do on yourself also. So do on your own, and I can just give you some. Do on your own. Do it yourself. Okay, the rest of it. So here you will see the balance. When you balance the equation, whatever equations you get, all you need to do is put the charges. So in the ionic equation, you are going to charge everything else, but do not charge. Do not charge the one that is a solid. Okay, so in this case, barium phosphate, you're not going to charge it. You're not going to break it into the ion. The rest of them will all be broken up into ions. Okay, and then based on the whatever you get the balanced equation, you just put charges. Rest on all, the ones that are aqueous, you are going to put charges. Okay, so in this case, net ionic is the ones in which the ions that show change of state. So you're going to put that change of state. Which ions are going showing the change of state? Now, just to give you an idea here, these guys, the barium phosphate. this one. So this one comes, the barium, all the barium phosphate ions. These are the ones. Remember, you look at it, phosphate is coming from the aqueous, barium is coming from the aqueous state, but it's going, so you're going to place those here, okay? So that's one thing. Now consider a reaction. Okay, this one, there's a mistake on this question. I think you should just put H2O. Oh, sorry. So in this, there is a little mistake here. Okay, here, just put H2O instead. H2O. H2O. Okay, and then this gives you H3O plus 1. Okay, so this is your new question here. So focus on this one. There's a little error here. Okay, so identify the acid. So here, the main thing is that you're going to identify which one is the acid. So keep in mind, do not start with water. Why? Because water can exist. Water is amphoteric, A-M-P-H-O-T-E-R-I-C, amphoteric, means that it can exist as an acid and a base. So we cannot, start with water. So we are going to look at that acid, which is commonly known. So sulfurous acid, this is called a sulfurous acid. Sulfurous acid. So it's an acid, okay? So we see H2SO4, H2SO3 is an acid. If H2SO3 is an acid, then the water is acting as a base in this case, okay? And then hydronium ion is the conjugate acid of water, and the sulfite ion is the conjugate base. So let me write this down. So H2SO3. So H2SO3 is an acid. And then if that is acting as an acid, then water is acting as a base. And every base has a conjugate acid. So H3O plus is the conjugate acid of H2O. Okay, remember that the difference between the conjugate acid base pair is the one hydrogen ion. And then the other one is the HSO3 minus is the HSO3 minus is the conjugate base of H2SO3. Okay, now you're going to use the table in the handout. Use the table in the handout. This answer, this is the table in handout. And that table, you have to compare the strengths of acid H2SO3 versus H3O plus. Okay, now this is just, if the table is not there, in the table, I saw it actually, H2SO3 is not there. But, so, I know this is another thing. So we can make it into H2 into this. Okay. So here, H2SO4 and here. Okay. So sulfurous acid is H2SO3 and sulfuric acid is H2SO4. Now, sorry about this little confusion here, but, just for the sake of, if you want to work with H2SO3, you can do some Google searches also. So check on the Google, which one is, stronger acid. So H2SO3 or H2SO4 versus H3O plus. So conjugate acid with an acid and a base with a conjugate base. So the base is water. And so we are looking at, in this case, water, H2O, and then versus the HSO4 minus 1. Okay, -1. So which one is more strong? So remember, the direction is from the stronger side to the weaker side. So you should know how to read that table. Okay. So this question relates to the table. I think it's table 11.3 in handout. Okay, this relates to that. Okay, now next are these math-based questions. Now I'm not going to do them for you, but I'm going to just list the steps how to do them. How many grams, so you need the grams of lead chloride, okay, are formed when 25 milliliters of 0.654 more KCl react with lead nitrate. So you are given a balanced equation. So here, what is the first step? The first step is you are going to take the milliliters. So take this information, milliliters, and molarity is given to you of KCl. You can find the moles. Okay, but first of all, convert milliliters to liters. That's the first step. Second step is you are going to find the moles of KCl by taking the molarity of KCl times the volume of KCl in liters. Okay, so this gives you the moles of KCl. Okay, third step, you're going to look at the mole to mole ratio. So you're going to find the moles of PbCl2, moles of PbCl2. How are you going to do that? You're going to take the moles of KCl and you're going to multiply it by the mole to mole ratio. And what's that mole to mole ratio of KCl and PbCl2? It's 2:1. So 1 mole of PbCl2 from the balanced equation and 2 moles of KCl. Okay, so this is the mole-mole ratio. That is going to give you the moles of PbCl2. So the next question is, how many grams is the PbCl2? How many grams of PbCl2? So you have the moles of PbCl2 and you're going to convert it into grams. How? You're going to need the molar mass. So moles of PbCl2 multiply by, right, the grams. So the grams means here, this is going to be the molar mass of PbCl2. Divide that by the 1 mole of PbCl2. And that will give you the grams of PbCl2. So this is your strategy or the steps you are going to follow. So all these questions are important. All of them are going to be on the test. The only difference is I may ask you to balance the equation first. So just so if you're not balancing the equation, then this thing is messed up. You see this mole to mole ratio. Mole to mole ratio comes from the balanced equation. So if a student has not balanced it, then everything goes wrong. Okay, so pay attention to balancing equation. And then the rest is, you know, calculating the molar mass, converting the milliliters to liters, all those things you need to do. Okay, so that's the number 3. Next is how many milliliters of lead nitrate molar. So the molarity of the lead nitrate is given, and we are being asked to find the volume in milliliters. Okay, needed to react with 36 milliliters of KCl. So here you are given the, here we are looking at the molarity. So I always see the students do that unless they know themselves how to incorporate the, what is it called? The moles. You know, do not use this formula. M1 V1 is equal to M2 V2. This is a dilution formula. In dilution formula, it's not a reaction. This is a dilution. It's best to keep things like this. Okay, and dilution formula is just adding water. No reaction, no chemical reaction in the dilution formula. And somehow some students, when they use this formula, they get it right only if the number of moles are the same. But we are looking at lead nitrate and KCl. So lead nitrate and KCl, the number of moles are not same. So that's why I'm saying that unless the students know how to incorporate those, you know, those moles, then don't use it. Okay, so what's the first step? Now here's an interesting part. You don't need to convert into milliliters here because the question is asking you, ideally you should, but the question is already asking you find it in milliliters, so you don't have to, you know, so you can keep it like that. So here is now the where is that? Okay, here, so first is find the moles of KCl. Moles of KCl is equal to the molarity of KCl times the volume. Okay, so just use that. Next is you're going to find the moles of, the moles of lead nitrate, Pb, NO3 whole twice. How will you find that? You're going to take the moles of KCl, okay, multiply by the mole to mole ratio. And here you see that 2 moles of KCl are reacting with 1 mole of lead nitrate, right? 1 mole of lead nitrate, and you get the moles of lead nitrate. Once you have the moles of lead nitrate, what's the third thing? So the third step here is you have, the molarity is equal to number of moles over the volume in liters. Next formula is, if you need to find the moles, then you take molarity times the volume. And if you need to find a volume, then you take the number of moles over the molarity. So you are given the molarity, you have the moles, then you can, so you're going to be using this formula. This one. Okay, you got the moles of lead nitrate, and you have the moles, so volume in milliliter in this case is equal to the moles of lead nitrate, Pb, NO3 whole twice, divide that by the molarity of lead nitrate. Okay, and that should give you the answer. All right, so this is the scheme that needs to be followed. We have done all these schemes in the lectures, in the homeworks, on the test. So you should have the mastery of these, you shouldn't forget it now. Okay, so the most critical thing, as I said, no matter what you do, you are all the time hitting the mole to mole ratio, mole to mole ratio, mole to mole ratio is this. So if you don't know how to balance the equation, that's like too bad. So you need to work on that, Okay, anyways, for the following reaction, the equilibrium constant is given. Okay, is given if the concentration of the products is 0.10 molar at equilibrium. What is the concentration of the starting material? What is the direction of the equilibrium? Okay, so you should know that the value of Kc in this case is given to you, but the products are, write down the formula, raised to the power 2, and then Br2 raised to the power 1 over the reactants. The reactants is NOBr raised to the power 2, right? So remember, this thing becomes it becomes raised to the power. All right, now you are given, we need to find the concentration of NOBr raised to the power 2 is equal to, we are given for if the concentration of both the products, so this value is already given. If the concentration of both the products is, what is the, okay, so for NO2, it's 0.10 raised to the power 2, multiply by bromine also 0.10, multiply, and then divide that by the value of Kc, which is 2.0. Okay, so whatever answer you get, you write that down, and the only difference is that the value of NOBr, okay? Remember, the opposite of square is what? Square root. So whatever answer you get, you will have to do the square root, okay? Whatever answer is there from this side. So simple math, okay? So whatever this piece is this. And then in order to remove the square root, that's why you do this. In order to move the square, that's why you do this thing. Okay, so that's how you will get the answer. All right, and that's the concentration of NOBr. What is the concentration of the starting material, NOBr? So that's how you will get. What is the direction of the equilibrium? So here, you see, once you get that, then you're going to compare whichever side is more, right? And then the Kc is already 2. So when the Kc value is 2, more than 1. So when the K equilibrium is more than 1, then that means the reaction is moving forward. So that means there are more products than the concentration of the products is more than the concentration of the reactants. Okay. So this type of similar questions, this is only one question. You need to look at other questions also. Okay, guys? Got it? All right. Next is how many moles of calcium chloride are in 250 milliliters of, so here volume. So learn to recognize the units. So this is the volume and this is the molarity. So convert the milliliters to liters. That's the first thing. Next is how many moles. So you know molarity is equal to moles over the volume in liter. And moles is equal to molarity times the volume in liter. So that's, for calcium chloride you will do. Next is, what is the molarity of a solution that contains 58.5 grams of sodium chloride? Okay, dissolved in 0.500 liters of the solution. Okay, so what are you going to do here? You have sodium chloride, know how to write the formula. Okay, so in this case, you're going to find the molar mass. Put that on one side. Why do we need the molar mass? Because we are given grams of NaCl and you're going to convert it into moles of NaCl, right? So how do you do this? You need the molar mass. So divide that. So basically, 1 mole of NaCl. So let me finish this here. So here is your over 1 mole of NaCl over the molar mass of NaCl. So that's going to give you that cancels out the grams, okay, and then gives you the moles of NaCl. Next is, what are you going to do next? What is the molarity? We need to find the molarity. And the formula for molarity is what? Molarity is equal to moles over the volume in liters. So you have the volume in liter, you get the moles of NaCl, you just plug it in and you get the answer. Okay. Next is a patient needs to receive 80 grams of glucose for 12 hours. What volume of 5.0 mass over volume glucose solution needs to be administered to the patient every 12 hours? So forget about 12 hours, right? They are giving you 85. So here lies this is testing your conversion factor. Okay. So 5.0% mass over volume. What is the meaning of this? This means 5 grams of, in this case, glucose. So 5 grams of glucose is present in 100 milliliters of the solution, okay? Or 100 milliliters of the solution, glucose solution contains 5 grams of glucose as a solid, okay? Glucose solid. Okay, so this conversion factors, 2 conversion factors from the percentage. Now, which one are you going to use? We need to cancel out the grams. We need to find a volume in milliliters. So what volume? What volume? And the volume in this case is always going to be in milliliters. So 85 grams of glucose multiply by, right, 100 milliliters of that solution over 5 grams of glucose. So you see grams and grams cancel out and you are just left with 100. So what do you get here? Whatever answer, 1700 ml. So the answers are given to you, but you need to do all the steps. Okay. Next is, what is the molarity of the KCl made by diluting? Now this is, pay attention to this. This is dilution problem. Dilution, you can't go wrong. Whenever there is a dilution question, that means you are simply adding water. Dilution means adding water. That's all. Adding water. And adding water does not mean that, you're basically lowering the concentration. Lowering the concentration. Okay? When you add water, you simply lower the concentration. So, but there is no chemical reaction. It's only a physical change. So no chemical reaction. So pay attention to this very important point here. You will never see a balanced equation in this case in diluting. Okay. Now, so this also means one thing. It means that your first step is M1V1 is equal to M2V2. This is the formula you will use. So what is the molarity? So we need to find the molarity of KCl solution made by diluting 75 ml of. So you are given 75 milliliters times, because I think on both the sides you have milliliters. So you can leave it here. You don't need to convert because both the sides, the units are the same. This is milliliters and this is milliliters. Okay. So 75.0 milliliters and then 0.200 m. Okay. 0.200 m times 75 is equal to M2 times V2 is final volume of 100 ml. Okay. So next is, just a rearrangement, and then that should give you the algebraic conversions. Okay. Next, consider a reaction in which, so these are all very important. All of them pretty much are going to be similar, will be on the exam. Okay. Not exact questions, but similar questions. Okay. So here you're given zinc reacting with HCl, giving hydrogen and it is zinc chloride. Okay, when 25 grams of zinc, so here 25 grams of zinc reacts with hydrogen, the question is how many liters of hydrogen gas are formed at 25 degrees Celsius and the pressure is 854 millimeters of mercury. Okay, so you are given the pressure, you're given the temperature. So convert degrees Celsius to Kelvin. So you should know how to do that. Add 273, right? Now, here we are looking at zinc and we are looking at hydrogen gas. So we are going to convert zinc to whatever information. So what's the first step? First step is find the moles of zinc. And how do you do that? You are given the 25 grams of zinc. Okay, times 1 mole of zinc over the molar mass of zinc. That's something you need to find yourself. Molar mass of zinc. Okay, that gives you the moles of zinc. Next, you're going to take the moles of zinc and do the mole to mole ratio. So moles of zinc are next converted to moles of hydrogen. So you take the moles of zinc times. So we see 1 mole of hydrogen is produced when 1 mole of zinc reacts. Okay, so that gives you the moles of hydrogen. And then the third is, because we have the pressure, the temperature, then that means we are going to use the formula PV is equal to nRT. Okay, so we need to find a volume. So this becomes nRT over P. All right, this is the formula you will use. So the value of R, so pressure, remember it's millimeters of mercury. Pressure, when pressure is in ATM, the value of R is equal to 0.08206 liter. Liter atmosphere per mole K. Okay, so this is one piece. But when the pressure is in millimeters of mercury, then it's a different value. Then the R is 66.4 liters times millimeters of mercury over mole K. Okay, so you're going to use this value of R. Okay, because you're given pressure in millimeters of mercury, you're going to convert the temperature and then the number of moles you already found from the top here. So this is this guy. The value of R, you have it, this one. The T, you have it. 1 second. Okay, here. So the temperature is Kelvin, is that, and then the pressure is, let's get another one. Pressure is this one. Okay, and so all these numbers, you know, that will give you you just plug those in and that will give you the answer. Okay, now the last one is, yes, you will be finishing up the presentation. Let me just finish this first, please. Okay, next is consider the reaction zinc with HCl, all this. So here you will see consider the zinc, and so when 25 grams of zinc, okay, reacts, and in this case, you're not given the pressure temperature, but you're given the value of STP. So temperature, you're going to use 273 K, and pressure, you can use 1 atm. And it's okay to use the value of R, which I already gave you in the previous. So that's the STP values. Okay. Next is, what is the pressure in millimeters? 4-gram sample of oxygen, temperature, volume. So here you are saying, what is the pressure in millimeters? So you're given 4-gram sample of oxygen gas. Okay. Which has a temperature is given 30 degrees Celsius. Volume. So same story. So 4 grams. So you are going to take 4 grams of oxygen and you're going to convert it into moles of oxygen. So this by now you should know. Okay. Once you get the moles of oxygen, number 2, you have the moles of oxygen. Okay. You have the temperature. You are going to convert into degrees Celsius, whatever it is, to Kelvin. Okay. And then the volume, is 3000 milliliters. Convert to liters. And then what is the pressure? So PV is equal to N or T, or P is equal to N or T over V. So we have the volume, we have the temperature, we have the R value, and we have the number of moles. So to just keep focus on this, we are needing the pressure in millimeters of mercury. Therefore, make sure you use the correct value. So use correct value of R. Okay. All right. Next is at STP. What is the volume of 4.50 moles of nitrogen gas? So when we talk about STP means, and we're talking about volume. So 1 mole is equal to 22.4 liters. All right. So at STP, that's what it means. And this means 1 mole over 22.4 liters, or 22.4 liters. 1 minute. Over 1 mole. Okay, so these are, so you're going to take, so 4.5 moles, how many moles? So these are you'll use the conversion factor. So use one of the conversion factor that gives you, what is a volume? So we need to find a volume. So don't forget that. We need to find a volume. So you're going to use this conversion factor. Sorry. Okay. Next, a sample of nitrogen gas has a volume. Now here you are given the volume, you are given the pressure, you're given temperature. What is the new volume of the gas when the temperature has changed to 50 degrees and the pressure is, if the moles are constant. Okay, so we have the volume, we have the pressure, temperature, a new volume of the gas that has a temperature and pressure. Okay, so this is this formula, P1, V1 over T1 is equal to P2, V2 over T2. Okay, so we need to find the volume. So you should rearrange this algebraic conversion and find what is the new volume. So we need to find the new volume. We need to find V2. Okay, so do the algebraic conversion. So I'm not going to, we already covered that in the class. So here, do sorry, algebraic conversion, sorry, algebraic conversions. Okay, all right, last, a sample of helium is cooled in a container to a temperature. What is the new pressure? So same thing, you are given a sample of helium at the temperature is given. You're going to convert the degree Celsius to Kelvin, okay? And ATM pressure. Pressure is given. Another is negative 73 degrees Celsius. What is the new pressure? So P1 over T1 is equal to P2 over T2. Okay, so P2. So same thing, algebraic conversions. All right. Next is about the limiting reactant. Now, this is, there is a, you know, these are very important questions, okay? And then the theoretical yield, okay? So here, these are the last two. So here you are seeing that you need to find a limiting reactant, okay? So some people are still struggling with the limiting reactant, okay? Oh, sorry, 1 second. I need to plug in my battery. I forgot to do that. Okay. Yeah, I'm not sure why this is running out of battery. But let's just quickly finish this because I don't want this to run out of battery. Okay, I'm not sure why this is running out of battery, but let's finish this before this runs out. All right, so anyways, find the mass of AlCl that is produced 10 grams of aluminum oxide and 10 grams of HCl according to the equation. So find the mass of AlCl3. This is a mistake students make. They start finding the mass of HCl. No, you're going to take 10 grams of Al2O3 and you're going to find how many grams of AlCl3 can you produce. All right. Similarly, you're going to take the 10 grams of HCl and you're going to find out how many grams of AlCl3 can you produce. All right. Got it. So how will you do this? You are going to, so you're going to take the grams of 10 grams of Al2O3, convert that to moles. Okay, 1 mole of Al2O3. And here is the molar mass of Al2O3. Al2O3. Next step is the mole to mole ratio between the moles of AlCl3 and Al2O3. So there are 2 moles of AlCl3 produced when 1 mole of Al2O3 is reacting. Next is you are going to convert the 1 mole of AlCl3. Remember, this is the moles, mole to mole ratio, moles. So these are moles. And then here is the molar mass of AlCl3. And that's going to give you the grams of AlCl3. You're going to similarly, same as above. The only difference is use HCl values. Okay? And then find out how much of HCl, the same setup as above. Same setup as above. And you will get the answer. So whichever one gives you the less, AlCl3 is the limiting reactant. Okay? So that's one piece. Next is when 10 grams of ammonia react, when 10 grams of the actual yield is given. What is the percentage yield? So write down the formula. Percentage yield. Always write formulas. Percentage yield is equal to the actual yield over theoretical yield times 100%. Okay, so here you see for NH3, when ammonia of nitrogen. So basically we are looking at the relationship of, so same thing you're going to take. You're going to take when 10 grams of ammonia. So 10 grams of ammonia, and you're going to write down how many grams of nitrogen are you producing. So this is your theoretical yield. Okay, so in this case, what are we doing next? We are same story as you did above. So 10 grams ammonia times 1 mole of ammonia. So this is the grams to mole conversion. Using the molar mass of ammonia, you need to find that out. Okay. Next is mole to mole ratio. So we see 5 moles of nitrogen are produced when 4 moles of NH3 are reacting. Next step is you're going to convert 1 mole of nitrogen and molar mass of nitrogen, molar mass of N2. And that gives you the grams of N2. And that is the theoretical yield. So you are given the actual, which is 8.50. You take the theoretical, you put that in the formula, and you will get the answer. All right. Next is the Lewis-Dot structures. So just make sure that you understand resonance. Okay, this is all covered in lectures. So you need to watch the lecture videos if you do not know how to do these. So plenty of lecture videos have,